Good morning, everybody. In previous class, that is yesterday, we were learned about the dioxygens. Preparation methods of dioxygens. Dioxygen can be prepared by laboratory method, then electrolytic process, and last one is the industrial method. After that, the physical properties of dioxygen can learn also, and then uses of dioxygens. Which are the physical properties? The physical properties of any compounds are demonstrated by their external appearance. Suppose external appearance of oxygens that possess, first, oxygen is colorless and odorless gas. It indicates oxygen does not have any color and any odor, but it is in gaseous in nature. That is physical state. Second point of the solubility, dioxygen is slightly soluble or sparingly soluble in water. So it shows dioxygen is soluble in water, but it is the smally in extent. Means what? Nearly about 30.8 cm cube of dioxygen is dissolved in 1000 cm cube of water. That is required to sustain aquatic life. Means what? Those animals which are lives in water, which requires the dioxygen for the respirations. So that oxygen is obtained from that water. So it dissolves partially. So all these physical properties, in which its freezing points also given, then it's paramagnetic in nature. Why oxygen is paramagnetic in nature? Oxygen possess a lone pair of electron on its. Due to presence of that lone pair of electron, it gives the paramagnetic in nature. After that, uses of dioxygen also discussed. First, very important use of dioxygen, that is, oxygen is used in respirations or respirations. In breathing process, all animals can take an oxygen and carbon dioxide is given out. So, for the any animals on earth, oxygen is very important. That is first use. Second use, oxygen can combine with acetylene to form the oxyacetylene flame, and that oxyacetylene flame is used for the cutting and welding of metals, generally which is used in welder shops. Those persons which undergoes the weldings of metals, for that purpose it required the oxyacetylene flame. Then oxygen cylinders are used in hospitals, and last use, oxygen is used for the combustion of fuels. So these are the uses of oxygen already seen in yesterday's. So in this class, see the chemical properties of dioxygen. Oxygen, how to react with other compounds, that is called as chemical properties. What is the reactions of dioxygens? First, reaction with metals. How to react dioxygen with metals? What is metals? Those elements can lose the electrons, are called as metals. For example, sodium, magnesium, aluminium, copper, zinc, all these are the metals. Dioxygen reacts directly with metals, except the Au and platinum. Means what? Dioxygen cannot directly react with the gold and platinum, but reacts with any metals directly. Why? Because gold and platinum are the precious metal. Therefore, oxygen cannot directly react with the gold and platinum, but reacts with other metals to form the metal oxides. For example, calcium reacts with oxygen, dioxygen to form the calcium oxide. Second example, magnesium reacts with oxygen to form the magnesium oxide. Another one, suppose sodium, it is very reactive metal. Sodium can react with oxygen. Sodium reacts with oxygen, then form the sodium oxide. Sodium oxide. For that purpose, we will require 2Na. Then it gives Na2O. Here 2, another 2. Sodium oxide. Likewise, that number of metal oxides can obtain. Suppose copper is given, gives copper oxide, aluminum oxides. So all these metals can react with oxygen to form the corresponding metal oxides. Second, reaction with non-metals. What about the non-metals? Those elements can gauge the electron for the completion of octet, or those elements which have tendency to gauge the electron called as non-metals. So how to react dioxygen with non-metals? Dioxygen reacts with non-metals like carbon, sulfur, nitrogen to form the corresponding oxides, except noble gases. Noble gases also non-metals, but noble gases cannot react with the dioxygen. Means what? Dioxygen reacts with non-metals like carbon, sulfur, nitrogen, except noble gases to give the oxides. For example, carbon is non-metal, reacts with oxygen to form the carbon dioxide gas. Then sulfur reacts with oxygen to form the sulfur dioxide gas. Another example, nitrogen N2 can react with oxygen to form the nitrogen dioxide. So carbon dioxide, sulfur dioxide, nitrogen dioxides, like to the oxides are formed when non-metals can react with dioxygen. Then third chemical property of dioxygen, that is reaction with some other compounds except metals and non-metals. Beyond that, when dioxygen reacts with hydrocarbon compounds, which compounds? Hydrocarbon. Means what? Those compounds can be made up from the carbon and hydrogens, called as hydrocarbon compounds. That may be methane, ethane, propane, butane, pentane, any. For example, CH4, methane is a hydrocarbon compound, can react with oxygen or burn in oxygen to form the carbon dioxide and water. Dioxygen can react with any hydrocarbon compound. Any hydrocarbon compound, that may be aliphatic, aromatics, cyclic, non-cyclic, then gives the carbon dioxides and waters. Likewise that, suppose sulfur dioxide is other compound than metals and non-metals, can react with oxygen to form the sulfur trioxide in presence of vanadium pentoxide. First, any carbon compounds reacts with oxygen to form the carbon dioxide water. Then sulfur dioxide reacts with oxygen in presence of vanadium pentoxide to form the sulfur trioxides. Next, 4HCl, that is acid. Hydrochloric acid can burn in oxygen in presence of cuprous chloride to form the chlorine gas with water. So all these are the chemical properties of dioxygens. Here dioxygen is completed. Then see the next part, that is oxides. What about the oxides? First of all, see the definition of oxides and then see the classification or types of oxides. First of all, oxides. What is oxides? Binary compounds. Binary means what? Those compounds made up from two or more than two. Actually, two. Those compounds are made up from two other, called as binary. a binary compounds of oxygen, with metals or non-metals. Binary compounds of oxygen with metals or non-metals are called as oxides. So this is the definition of oxides. For example of binary compounds, for example, first CaO, calcium oxide. This compound is made up from two. One is the oxygen and another is the calcium. Calcium oxide is best example of oxides. Second, Na2O, sodium oxide. Then sulfur oxide, sulfur trioxide, aluminum dioxide, Al2O3. So all these are the examples of oxides. Then classification of oxides or types of oxides. Classification of oxides. Oxides are classified by three ways. It classified by three ways. First is the acidic oxides. Second, basic oxides. Third, amphoteric oxides. Actually, these are the main three classification of oxides. First is the acidic oxide, second one is the basic oxide, and third one is the amphoteric oxides. So what about the acidic oxides? Acidic oxides is what? The oxides dissolved in water to produce acid. The oxides dissolved in water to produce acid called as acidic oxides. The oxides dissolved in water. The oxides dissolved in water to produce acid. The oxides dissolved in water to produce acid or reacts with base to produce salt called as acidic oxides. Second, the oxides dissolved in water to produce acid or reacts with base to produce salt called as acidic oxides. For example, first example of acidic oxide, that is SO3 sulfur trioxide. Suppose dissolved in water, then it gives the H2SO4 sulfuric acid. SO3 dissolved in water to produce sulfuric acid means what? SO3 is the acidic oxide. Other ways, suppose this SO3 reacts with base NaOH, sodium hydroxide. SO3 reacts with base NaOH. Then it forms salt, Na2 SO4 plus H2O. See again example, sulfur trioxide, sulfur dioxides, sulfur trioxide or sulfur dioxides are the examples of acidic oxides. Why? Because it dissolved in water to produce acid. Sulfur trioxide dissolved in water to form sulfuric acid. Other, it reacts with base to form the salt and water. Therefore, SO3, SO2 are the examples of acidic oxide. These are the examples of acidic oxide. Second is the basic oxide. What about the basic oxides? Basic oxides. The oxides dissolved in water. The oxides dissolved in water to produce base. The oxides dissolved in water to produce base or reacts with acid or reacts with acids to produce salt, called as basic oxides. For example of basic oxide, suppose calcium oxide, CaO, calcium oxide dissolved in water to form the calcium hydroxide is the base. Calcium oxide dissolved in water to produce the calcium hydroxide is the base. Therefore, calcium oxide is the basic oxide. Suppose this calcium oxide reacts with acid HCl. Reacts with acid HCl. Then it gives the calcium chloride salt and H2O. So this calcium oxide indicate basic oxide because dissolved in water to produce calcium hydroxide base or reacts with acid to form the salt and water. Therefore, it is basic oxide. Then third one is the Ampoteric oxide. Next oxide, third is the Ampoteric oxide. So what about the Ampoteric oxide? The oxides reacts with acids as well as base to produce salt and water. The oxides reacts with acids as well as base to produce salt and water. The oxides can react with acids as well as base to produce salt. The oxides can react with acids or base to produce salt, called as Ampoteric oxides. For example of Ampoteric oxide is the Al2O3, alumina. Al2O3 is the example of Ampoteric oxide. Suppose Al2O3 is acidic in nature. Al2O3 is the Ampoteric, can shows both property of acid, salt, base. How to produce acidic in nature? Whenever it reacts with base, in aqueous medium. Then it produces the salt. Then it produces a salt, which alumina reacts with sodium hydroxide base in aqueous medium to gives this salt, sodium aluminum hydrate. Sodium aluminum hydrate is the salt. Suppose then this alumina is basic in nature. How to indicate the basic nature of that alumina? Can react with 6HCl, that is acid, in aqueous medium. In alumina reacts with acid in aqueous medium, then it gives then it gives a salt, aluminum hydrate plus 6Cl minus. So this is amphoteric oxides. Those oxides can react with acids or base to produce salt called as amphoteric. For example, alumina. In first, this alumina can react with base to form the salt, so it is acidic in nature. This alumina reacts with acid to form the salt, so it is basic in nature. This alumina can indicate both property of acid as well as base, so amphoteric in nature. And last one is the neutral oxide. Neutral oxides. Actually, oxides can use only three classifications. First, acidic, basic, and amphoteric. And another one is added, that is the neutral oxides. What is neutral oxides? The oxides which are neither acidic nor basic. The acidic or basic nature cannot indicate, called as neutral oxides. The oxides which are neither acidic nor basic in nature, called as neutral oxides. For example, CO, carbon monoxide, NO, nitric oxide, N2O, etc. All these are the examples of neutral oxides. Means what? It cannot show the acidic and basic oxides. So here, oxides and their classification is given. Can ask for the 3 marks. Okay.